Hey everyone, today we will be looking at the decimal places. So in this video, we will be exploring what is a decimal place and the rounding rule, and lastly, the NAPLAN question types. There are three types of questions that can appear in NAPLAN about the decimal places. First one is rounded to specific decimal places. The second one is to the nearest whole number or unit. And finally, rounding as part of estimation, approximation, and unit conversion. All the materials being adapted from the Essential Mathematics for the Australian Curriculum, 3rd edition, Cambridge University Press. What is a decimal place? Well, imagine a number line is like a ruler. And on the number line, you will see 0, 1, 2, 3. These are the whole numbers, and they're the big steps. But what if you want to show the tiny steps between numbers, like between 1 and 2? So let's talk about the numbers between 1 and 2. You might already know that 1.5 is exactly in the middle of 1 and 2. It's like saying 1.5. But did you know that there are many numbers in between 1 and 2 and not just 1.5? Let me show you a few examples. Right after 1, we have 1.5. Oh, sorry, 1.1. Then we have 1.2. Then we have 1.3. Then we have 1.4. Then 1.5. We are only halfway there. But after 1.5, we still have 1.6, 1.7, then 1.8, and then 1.9, and then 2 comes in. Each of these is called a decimal number because they show parts of a whole using a decimal point. But zooming in even more, if we zoom in between 1.1 and 1.5, there are even more decimal numbers. Let's say I am talking about decimal points in between 1.1 and 1.2. I might divide many different parts, and I'll write 1.11, and then there's so many. I can keep going. 1.12, and the list goes on. The same goes with this. Between 1.2 and 1.3, I could say it's somewhere between. Halfway of 1.2 and 1.3, there will be 1.25. And also, somewhere between 1.3 and 1.4, not at halfway, but a little bit over halfway, I could write 1.37. And the list goes on. That's a cool thing about decimals. They are indefinite steps between any two whole numbers, like 1 and 2. So all you gotta do is think of it like a ruler, number line, or a ruler shows us these steps clearly, and each step is like 1/10 of a number. Now, each place has a special name. So let's say the number 1. It is our number. It's a whole number. And then a decimal point comes in. We use a little point. And then the first number that comes after the decimal point. Let's take 1.111 for an example. So that will be our first decimal place, 1. And the second decimal place, another 1. And then the third decimal place goes on. We can also call the first decimal place as our tenths. The second decimal place, hundredths. And the third decimal place, thousands. And it goes on. We already know the whole number here before the decimal place, it's called ones and then tens. If they imagine there will be numbers in front, we can say there is, let's say 321.11 before the decimal point, ones, tens, hundreds, thousands, and it goes on as well. One thing to note is after decimal point, the special names ends with THS, and there is no ones. It starts from tens, hundreds, thousands, and it goes on. Now that we all know the special names of the decimal places, we're going to look at the rounding rule. Well, it's actually pretty simple. There are only 2 steps in rounding rule. You find the place you're rounding to, and then you look at the next digit, it's bossy digit. Then if the bossy digit is 0 to 4, we stay the same. If it's 5 to 9, you go up by 1. Okay, let's do a few more examples. So round these numbers to 2 decimal places. 2 decimal places. First step to determine where is our 2DP. So we're going to count from our decimal point 1, 2. So the 2 decimal place is up to 3. We need to cut off the number up to 3. All right, so where is our bossy digit? The bossy digit is always after our determinant decimal point place. So 3 is our bossy digit. Is it between 0 to 4? Yes, it is. So the number before our bossy digit, it's gonna stay the same. So let's write this number now. It's 0.03 will be our answer. We have rounded to 2 decimal place. So I want you to have a go at a few examples at the bottom. A, B, C. Materials being adapted from Essential Mathematics for the Australia Curriculum 3rd edition, Cambridge University Press. If you want more examples, please refer to this textbook. So now, let's have a look at 3 different types of NAPLAN questions. So the first type is rounding to specific decimals. And I'm just going to go through just one question for each type, and then you can go ahead and do the rest at your own time. And all the questions here will be available in the description or comment below. The first question is 2016, question 19 on page 7. This is a calculator question. Jenny asked 35 people whether they work, go to school, do both, or do neither. The Venn diagram below shows the results. If a question is showing you the Venn diagram, you look at it and you try to unpack. Works there are 14, and for school there are 16. 3 people go to work and school. There are 2 people who do none. What is the probability that a person randomly selected from the group go to both school and work rounded to 3 decimal places? As you can see, this is asking you to solve the problem first and then rounding to specific decimal places. We know that there are people who do both work and school. It's 3. So the question is asking you the probability. So we know that probability formula is 3 little here. People go to both work and school. And what is the total number of possible outcomes? So it's just adding the whole thing up, which is 614 plus 3 plus 16 plus 2 out of the total people we get. So I'm just going to pop this 3 out of 35 in the calculator, 0.08571 the whole thing goes on. But it only needs us to round it to 3 decimal places. So where am I looking at for 3 decimal places? I'm going to count again from my decimal point. 1, 2, 3. So the cutoff is here. The first step, we already know where it's going to cut off. It's 0.085. And the second step, we're going to look at our bossy digit. Bossy digit is 7. Is it between 0 to 4? Nope. But is it between 5 to 9? Yes, it is. So we know that it's the number before our bossy digit, number 5, needs to go up by 1. So I'm going to round here. It's 0.086. Let's have a look at our options in this one, and D will be our answer. Now that I have done one example, you can do the rest on your own. Again, these materials are from NAPLAN 2012 to 2016 and 2011 test papers, Australia Curriculum Assessment and Reporting Authority, ACARA. So if you want to have the whole question pack, please refer to their website. Now let's have a look at another question type. So this one is rounding to the nearest whole number or unit. So 2013 question 4 on page 3. So this table shows how many people attended 3 football games. This is a calculator question again. To the nearest 1,000. What was the total number of people attending the 3 games? So it's asking, first step, we need to find the total number. What I'm going to do, I'm just going to pop that in my calculator of these number of people attending. It gives me 157,718. So we're just going to put that in our little table. What I like to do is I like to sort these out by places. So remember, our numbers has their own special name, and before our decimal point here, we have ones, tens, hundred, thousands, 10,000, 100,000. It's just asking you to the nearest 1,000. The cutoff is so I'm going to pop this number 157,718 to this little table. I'm going to start from my last digit. It's ones place. 8, 1 will be in 10. 7 will be in hundreds. Another 7 will be in thousands. And 10,000. 5 will be in 10,000. 1 will be in 100,000. The first step, we already know where the cutoff is. The second step, we need to look at our bossy digit again. So the bossy digit, is it 0 to 4? Nope, it is not. It's between 5 and 9. Yes, it is. Before, our bossy digit needs to go up by 1. So the answer will be approximately 1, 5. Needs to go up by 1. 7 plus 1 will be 8. 0, 0, 0. Answer will be C. Let's have a look at our third question type. This is about rounding as part of estimation, approximation, or unit conversion. This is a non-calculated question. You can see I could only find is just one question. Which of these is the longest longest distance? This question was in 2010, question 15 on page 6. So we need to find which of these is the longest distance. First, we can go one by one and have a look at the units. So from the look of it, I can see kilometers, meters, centimeters, and millimeters. They're all different. What can I do is I can pick one measuring unit and try to convert all of them into that same unit. And from the look of it, uh, I'm gonna pick 123, the meter one, because it seems like I can easily convert centimeters or millimeters to meter and also to the kilometers to meters. So it's somewhere between, the unit is somewhere between kilometers, centimeters, and millimeters. That I've decided which unit I'm going to convert into. I'm going to go one by one. So for A, it is 0.1203 kilometer. I'm just going to copy this. So we know that 1 kilometer is equal to 1,000 meter. We want to know how many meters are in 0.1203 kilometers. Well, all you got to do is to multiply it. We want to change from kilometers to meters. We can multiply it by 1,000. So when we multiply it, there's a simple rule. We just move the zeros from the decimal point. We count it 1, 2, and 3. We just have to move the little decimal point to 1, 2, and 3. It gives us 1, 2, 20, 120.3 meters. B, well, the B is already in meters, so we don't have to change. And let's have a look at our C, 1,230 centimeters. So we know that 1 meter is equal to 100 centimeters. We can write either way, 100 centimeters equal to 1 meter. So how many centimeters are there? 1,230 centimeters. So how much is 1 centimeter in 1 meter? So we can do this thing. 1 centimeter is equal to 1 divided by 100. 1,230 centimeters equal to, I'm going to multiply this to 1,230 centimeter. And it gives me 100, like this, 1,230 divided by 100. So we can cancel the zeros. And when I divide 123 by 10, there is only 1 zero here, right? There are always an imaginary decimal points in numbers. For example, 1, 2, 3. Take this as an example. This is our whole number. After a whole number, there are always zeros followed by a decimal point. So if we divide that by 10, we're going to move that decimal to 1 0 place because there's only 1 0. So it became, the answer is 12.3 meter. So that's our C. We get 12.3 meters. Sorry, I forgot to write for our A. We get 120.3 meters. Well, for D is 12,030 millimeter. Well, for this one, we're going to change to meter again. 1 meter is equal to 1,000 millimeter. We want to know how many meters in 12,030 millimeters. To do that, we can write 1 millimeter is equal to 1 divided by 1,000. 12,030 millimeters equal to 1 divided by 1,000 multiply 12,030 millimeter. Again, we're going to use that decimal place division thing here. It's going to give us in meter unit. Don't forget the units, otherwise you're going to mix all that up. We can cancel the zeros when we are dividing, and when we divide the 100, there are two zeros in here, so we're going to move our decimal point, imaginary decimal point, to backward 1 2 places. There we have our answer, 12.03 meters equal to 12,030 millimeters. Now we only have worked out all the distances in the same units. Now we have to figure out which of these is the longest distance. Well, we gotta compare. We already know these two C and D are out because it is way below 100. It's just 12.3 and 12.03 meters, so they're all out. So we need to choose the options between A and B. Is it 123 or is it 120.3? Well, we can see 123 is obviously greater than 120.3. So the option is answer B.